Please do share this with your friends who are preparing for CAT and other MBA entrance examinations. You can like and follow us on Facebook as well as subscribe to our YouTube channel to get live event and notifications for all the updates regarding CAT and other MBA entrance examination. You can also look at our WhatsApp as well as Telegram lists. You can join over there and we will update you. We don't spam over there. If you want, you can enroll for our Quant and LRDI courses. These are the best and the most comprehensive courses available in the market. In this session, we'll be looking at quadrilaterals. We'll also be solving a few questions which came up in the past CAT and XAT papers. I'd suggest pause this video, have a look at the PDF. The link is available in the description of this video with all the questions and the answer key. Once you have tried this on your own, then proceed with the rest of this session. Please do share this with your friends who are preparing for CAT and other MBA entrance examinations. You can like and follow us on Facebook as well as subscribe to our YouTube channel to get live event and notifications for all the updates regarding CAT and other MBA entrance examination. You can also look at our WhatsApp as well as Telegram lists. You can join over there and we will update you. We don't spam over there. If you want, you can enroll for our Quant and LRDI courses. These are the best and the most comprehensive courses available in the market. Quadrilaterals are very frequent in the CAT examination, right? Without any special conditions, you will have to divide a quadrilateral into 2 triangles or 4 triangles and then evaluate it, right? As discussed previously, all the relations that we deal with in polygons, etc., will be with convex polygons unless otherwise specified. So if you have not seen the session on polygons and their classification, I would suggest please do have a look at that session as well. The link is available in the description of this video. So a general quadrilateral will have 4 corners and 4 sides, right? Nothing special about it except for the fact that the number of diagonals is 2 and sum of internal angles is 360 degrees. Right. If you restrict the quadrilateral to such that the corners lie on a circle, on the perimeter of a circle, then such a quadrilateral is called a cyclic quadrilateral. For such a quadrilateral, some of the opposing angles will add up to 180 degrees. So A and C will add up to 180, B and D will add up to 180. For such a quadrilateral, we can find the area if we know the 4 sides. It's like an extension of the Hero's formula for triangles. Remember, only for cyclic quadrilateral this is applicable, not for any general quadrilateral. So it will be square root of s minus a into s minus b into s minus c into s minus d. There is no s term, right? And s is the semi-perimeter, right? You also have a Ptolemy's theorem for cyclic quadrilateral. It is there in your most textbooks, so I've just mentioned it over here. It's hardly used in CAT examination as such. If you want to know it, it's the product of the length of the diagonals equals sum of the product of the length of the opposing sides. So AC into BD will add up to AB into CD plus AD into BC, right? Now, if we restrict the 2 sides of a quadrilateral to be parallel, 2 opposing sides to be parallel, then you get a trapezium. In American texts, you will refer to them as trapezoids, right? So suppose in this quadrilateral, PQ is parallel to SR. Then you have all the properties of parallel lines also applicable over here. So angle P plus angle S will be 180 degrees and angle Q plus angle R will also be equal to 180 degrees, right? And we can find the area. Area will be average of the parallel sides times the distance between them, right? Average of the parallel sides times the distance between them. So that way you can find the area. Okay. Again, you can prove it using properties of a triangle pretty easily. Now, if you restrict the other set of non-parallel sides also to be parallel, then you get a much more easier figure to deal with. It's a parallelogram, right? Now, the opposing sides are parallel. So PQ is parallel to SR, PS is parallel to QR. The opposing sides are also equal. PQ will be equal to SR, PS will be equal to QR, right? Perimeter will be twice of length plus breadth. Breadth supposing is the smaller side, length is the longer side. Area will be base into height. Now there are two heights possible. One is taking QR as a base, that will be height h2, or SR as a base, in which case it will be height h1. Right. The other way of finding out the area of a parallelogram is product of the two adjacent sides times the sine of the angle between them. Right. This comes from the sine angle for triangles. Right. So you can prove it also pretty easily. Proof is available in most texts. Right. Another property is, given the symmetry of the parallelogram, the diagonals of a parallelogram bisect each other. Right. So PR will be equal to XR. SQ is equal to XQ. Now they need not be equal to each other. If they become equal to each other, diagonals, then you will have a special parallelogram. We will deal with it later on. Right. Also, there is another theorem which is there. Sum of the squares of the sides equals the sum of the squares of the diagonals. So PQ square plus QR square plus SR square plus PS square will be equal to PR square plus QS square. Right. Again, the proof is available in most texts if you want to try it out. Let's use these basic properties of quadrilateral, cyclic quadrilaterals, trapezium, and parallelogram to solve a few questions which came up in the past CAT and XAT examinations. First one is from CAT 2001, right? It says two sides of a plot measure 32 and 24, and the right angle between them is a perfect right angle. So 34 and this is a perfect right angle. The other two sides measure 25 meters each. The other three angles are not right angles. What is the area of the plot? Right. Given besides this, we don't have anything else, right? We cannot say that this is a cyclic quadrilateral also, right? It's not a parallelogram, it's not a trapezium. We'll have to divide into two triangles. So let's try to divide them into two triangles, right? So if I draw this line, right, given this is a right angle, so let's name them A, B, C, and D. AC becomes the hypotenuse to the triangle ABC, right? Also, ADC is an isosceles triangle. So if you drop a perpendicular to it, it will bisect it. It will bisect the base, right? So we can analyze it in this way. Okay, what do we need? We need to find the area of the triangle. Now, area of the quadrilateral. Area of the quadrilateral will be area of triangle ABC plus area of triangle ADC. For ABC, it's pretty straightforward. Half base into height. We know the base and the height. Right, so half of 24 into 32. Right, so 24 into 16, that's 20 minus 4 into 20 plus 4. Right, so that's 20 square minus 4 square. Right, 20 square is 400, 4 square will be 16. So this will be 384. Right, now what will be the area of triangle ADC? Now to find area of triangle ADC, we need to find the height and the base, or the third side if you want to use the hero's formula. So let's try to find the hypotenuse of this. 24, 32, this is 3 into 8, this is 4 into 8, so this should be 5 into 8, which is 40. Right, so this length is 40. Now you can use the hero's formula, or you can drop the perpendicular. Right, so 40 is the full length, so this side will be 20. 20, 25, this is a right angle triangle, so this should be 15. Right, this should be 15. Right, 3 into 5, 4 into 5, 5 into 5. Again, another 3, 4, 5 right angle triangle. What will be the area of this? Half of height is 15. Now base will be, I need the full base. Full base will be 40. Right, so 20. 20 into 15 will be 300. Full area will be 384 plus 300, 684. Option D will be your correct choice. Need to be a little patient. it takes longer to explain than to actually solve. Identify the right angle triangles, identify the isosceles triangle, job done. Second question is from XAT 2014. Right, this basically uses triangle inequality inside a quadrilateral. Let's see what this says. In a quadrilateral PQRS, PQ is equal to 5, QR is equal to 17, RS is equal to 5, SP is equal to 9. What is the length of the diagonal? QS. Okay, so you have PQ will be equal to 5, QR is equal to 17, slightly longer, RS is equal to 5, right, and SP is equal to 9. Right, you need to find the length of the diagonal QS. Right, so this is S, this is 5, okay, SRS 5. Okay, you need to find the length of diagonal QS. Now, if you look at the diagonal QS, right, it is also a part of a triangle, right? For example, PQS is a triangle, QRS is also a triangle. So the triangle inequality will hold. So sum of any two sides should be bigger than the third side. Sum of any two sides should be bigger than the third side. So if this is X, we know that X has to be less than 9 plus 5. And X has to be less than, if I take this triangle, 17 plus 5. So 9 plus 5 is 14. 17 plus 5 is 22. So the highest possible is 14. Highest possible value is 14. Right. So this looks like a nice one. Let's look at the lower bound also. If you want to look at, these two are straight away out. Right. If you want to take the lower bound also. Now again, if you use the same triangle inequality, sum of any two sides has to be bigger than the third side. So if you take this triangle, 5 plus X has to be greater than 9, which means X has to be greater than 4. Similarly, if you take QSR, X plus 5 has to be greater than 17, which means X has to be greater than 12. So the minimum value has to be at least 12, right? Minimum value is 12, maximum value is 14. Bounds are open bounds, right? So option B will be our correct choice. Pretty straightforward application of your triangle inequality under 2 minutes in an exam situation. Job done. The third one is from CAT 2018, slot 1. It says in a parallelogram ABCD of area 72, the sides CD and AD have lengths 9 and 16 respectively. Let P be a point on CD such that AP is perpendicular to CD. Right? Then the length in square centimeter of APD is how much? Okay, so you have something perpendicular to CD. Right. This is 9, this is point P. Okay, and you have AP, right? So if I take this, I need to draw a parallelogram. So you have A, D, C, B, right? So this is 16, right? This is roughly to scale, right? Now the question is, let P be a point such that AP is perpendicular to CD. The area in square centimeters of APD. APD is how much? What else is known? The area of the parallelogram is 72. Now area of the parallelogram is 72. What is area? Area is base into height. So 9 into height. Height will be AP, will be 72. What will be AP now? So half of, not half, 9 into AP will be equal to 72. So AP should be equal to 8. Right, now this is a right angle triangle. 9, we don't know this part, X, and this is 16. So 16 square minus 8 square root should be equal to X. Using Pythagoras theorem, 16 square is 256. 8 square is 64, square root equals X. So X should be square root of 192. I need to split 192. 192 is 64 into 3. 64 is 8 square. So 8 root 3 will be equal to X. Now that is not the question. The question is, what is the area of triangle APD? Area of triangle APD will be half of AP into PD. Base into height. right? So it will be half of 8 into 8 root 3. 4 into 8 root 3 is 32 root 3. Option 4, job done. And the last one is from CAT 2018 slot 2. Right? It says a parallelogram ABCD has area 48. Length CD is 8. AD is S. Which of the following is necessarily true? Okay, so we have CD is 8. AD is S. Right? Area is 48. So we need to find the range of S. Range of S. Now, one we know is base into height, but height is not known. Right? So we know 8 into S into sine of angle D should be equal to 48. Right? So which means S into sine of angle D should be equal to 6. Now, so the value of S should be equal to 6 divided by sine of angle D. Now, the value of a sine will be definitely less than or equal to 1, which means S has to be divided by a value which will be less than or equal to 1. If you put 1 over here, then it will be 6. As the denominator keeps on decreasing, the value will keep on increasing, right? Which means the lowest possible value is 6. So option 2 will be your correct choice. The other way, if you don't know the sine part, is let's look at base into height. Right, base is 8. Right, so S can be, the triangle can be shaped like this. The triangle can be shaped like this. The triangle can be shaped any which ways. Right, so base into height is equal to 48. So base is 8. So height should be equal to 6. Right, so the best you can do is if the height and the side coincide. Right, otherwise the side will be greater than equal to 6. If you don't know the sine rule, even then you can answer this question. So the has to be greater than or equal to 6. It will be equal to 6 when this becomes perpendicular, becomes a rectangle as such. But even without knowing the sine rule, you can still answer this question. So that completes this session on quadrilaterals, the first part. In the next one, we will look at even more restrictions on parallelograms, which is rhombus, square, rectangles. They are even more frequent compared to this. Again, polygons, quadrilaterals, pretty frequent. You usually get 2 to 3 questions in each CAT paper. Make sure that you apply basic concepts of quadrilaterals, triangles, etc. to solve these questions. That completes this particular session. If you liked it, please do share it with your friends who are preparing for CAT and other MBA entrance examination. Please do subscribe to our YouTube channel as well as follow our Facebook page. The links for our course are available on the description to this video. Till we meet again the next time, goodbye and all the best.